All right, hey everyone, good afternoon. So today we're going to be continuing to talk about the rational zeros theorem, and we're going to use this theorem to graph polynomials. So as you can see from the do now, we have this polynomial x to the fourth, etc., all the way to plus 16. For part A, I want you to use the rational zeros theorem to list all possible rational zeros, check if they're actually zeros of px, and then for part B, from there you can factor, and then for part C, we'll graph. See if you can start on part A and maybe part B, but I'll give you another minute to do that. So don't worry if you don't finish. It's kind of a long problem, but yeah, we'll go over the solution together in 1 minute. All right, so let me pause you here. I'm gonna scroll up for the solution. All right, so the possible rational zeros, using the rational zeros theorem from yesterday, plus minus p over q. Remember that p represents the factors of the constant term. In this case, it's 16. So it's 1, 2, 4, 8, 16. The q variable represents the factors of the leading coefficient. In this case, it's 1. So it'll be plus minus, every combination. You just take the numerator because there's only one number in the denominator. Okay, so it'll be 1, 2, 4, 8, 16. And I'll go ahead and tell you that negative 2 is a 0. And, just like yesterday's homework, feel free to use a graphing calculator to check which ones are the actual zeros and use that to help you factor the polynomial. Okay, so do the same thing for this homework as well. Anyways, negative 2 is a 0, and we're going to use synthetic division to divide. So here are the coefficients, 1, 8, 24, 32, 16. Bring down the 1, you get 1, multiply, you get negative 2. Add that, you get 6, multiply, you get negative 12. Add that, you get 12. Multiply, you get negative 24. Add this, you get 8. Multiply one more time, we'll get negative 16, which gives us 0 as our remainder. Okay, so the polynomial can therefore be written as x plus 2, right? That's what we gathered from this, right? Negative 2 is a 0, so x plus 2 is a factor. And then x cubed plus 6x squared plus 12x plus 8, which we got from here, is the quotient. That's the other factor that we can break it up as, right? Okay. All right. I'm going to divide one more time. So actually, it turns out that negative 2 has a multiplicity of 4 in this polynomial. So I'm going to divide this quotient here from this, right, by negative 2 again, or x plus 2, the factor. Okay, if we do that, we're going to get the following. So we have 1, 6, 12, 8. Remember, we're dividing this x cubed polynomial by x plus 2. Drop down the 1, multiply, you get negative 2. Add that, you get 4. Multiply again, you get negative 8. Add this, you get 4. Multiply, you get negative 8, and you get 0. So therefore, we can write the polynomial as x plus 2 times x plus 2 times x squared plus 4x plus 4. Okay. Now that we have a quadratic, we can now factor easily without using synthetic division. So we can write this as x plus 2 squared, right? So x squared plus 4x plus 4 is x plus 2 squared. So therefore, this polynomial can be written as x plus 2 to the fourth power. Okay, I'll pause right there to allow you to copy parts A and B, and then we'll move on to part C. Question?
Why did you divide again?
Yeah. So it actually this is like actually the first time we're doing this, so it's a good question. There isn't really anything you can tell from the polynomial that tells you that uh, -2 has a multiplicity greater than 1. Um, but yeah, so all you can really do is like, uh, yeah, so in this case, use a graphing calculator really. That will tell you. So yeah, there's nothing, at least from what we've learned in this class, like that'll tell you that -2 appears again as a 0. Um, yeah, besides the calculator. So yeah, it's just like it's just basically a random guess actually. If you weren't using a calculator, I mean.
Thank you.
Okay, but yeah, let me emphasize that point. So -2 has a multiplicity of 4 here in this case. So this polynomial here, the original, is just x plus 2 to the fourth power. Right, so -2 has a multiplicity of 4. So it's x plus 2 times x plus 2 times x plus 2 times x plus 2. But yeah, there's nothing you could, you know, uh, you can't really tell that from the original. But yeah, that would just be a guess without the calculator. Okay, so let me move on to part C. For part C, we're going to graph using the end behavior. In this case, the end behavior, right? So let me scroll up to the original polynomial. It was x to the fourth, right? So x to the fourth is our leading term. So 4 is an even power. So it'll have, it'll go either positive or negative in both directions. But it's positive x to the fourth, so it'll be positive in both directions since we have a positive leading coefficient. Okay, so this is how we would write the end behavior as x goes to negative infinity, y goes to infinity, as x goes to positive infinity, y goes to positive infinity. The y-intercept, for that we just plug in x equals 0, and for that we'll get 0, 0, 0, 0, right? And then we end up with positive 16. For the zeros, it's -2 with a multiplicity of 4, as we saw in part B. Okay, and then from there we can graph. Okay, so -2 has a multiplicity of 4. So if you remember from that multiplicity lesson earlier on in the unit, if it has an even multiplicity, right, 4 is an even number, then it's going to bounce off the x-axis. If it had an odd multiplicity, let's say like 3 or 5, then it would go through the x-axis, right? It would pass through. Okay, but in this case, even multiplicity, which means that it'll bounce off the x-axis. Yeah, that's your x-intercept, -2. The y-intercept, which I didn't show here, that will be up there. And then the end behavior is positive in both directions. So for the graph, I would, of course this is Desmos, so this is the actual graph, but for your notes and the homework, you can draw an approximation, right? As long as it's consistent with the information that we've gathered leading up to the graph. Okay, so positive infinity in both directions, -2, multiplicity of 4, y-intercept of 16. All right, I'll give you another 30 seconds to copy that, and then we'll move on to the example. Okay, does anyone still need the solution here? Okay, if not, then I'll move on. Okay, so the rest of the lesson is just practice with this type of problem. We're going to use the rational zeros theorem and then from there graph. Okay, so we have an example and then after that it's just two practice questions. All right, so this graph is 2x cubed minus 7x squared plus 4x plus 4. Using the rational zeros theorem, plus minus p over q, you get, oh, I'm there. Sorry about, oh. All right, plus minus p over q. P represents the factors of the constant, which are 1, 2, and 4, and then the factors of 2, which is 1 and 2. That's the denominator, okay? All right, first thing I'm going to do is just do 1 divided by 1 is just 1, 2 divided by 1 is 2, 4 divided by 1 is 4, and then you can try the other option, which is 1 divided by 2, which is 1 half, and that gives us a new possible rational zero. 2 divided by 2 is 1, so we don't have to rewrite that. And then 4 divided by 2 is 2, which we already have also, so we don't have to write that either. Okay, so these are the possible rational zeros. For the actual testing, so I'm actually going to skip to the number 2 because I know that that's a 0. Okay, so just for the sake of time, I'll, 1 and negative 1 don't work. Okay, so I'm going to skip to 2. So 2, we have these leading coefficients, 2, negative 7, 4, and 4. Okay, so drop down the 2, multiply, get 4, add that, you get negative 3, multiply again, you get negative 6, add that, you get negative 2, and then multiply, you get negative 4, which gives you 0, which means that this polynomial can be written as x minus 2 times 2x squared minus 3x minus 2. Okay, and then from there we're going to factor. But for now, I'll give you a sec to copy that. Again, note that I didn't go through this just for the sake of time, but yeah. This is how you do it, manually by hand if you did not have a calculator. Okay, so let me keep moving. So we're going to factor 2x squared minus 3x minus 2. Okay, so I'm going to use the AC method, right? So we have 2 times negative 2. So we have to think of two numbers that multiply negative 4 and add to negative 3, which is the linear term, right? The linear coefficient. So the two numbers that multiply negative 4 and add to negative 3 are negative 4 and positive 1. So I'm going to rewrite negative 3x as negative 4x plus x minus 2 at the end. So the first two terms are going to factor out 2x. You get 2x times x minus 2, and then plus 1. Well, 1, you factor out 1 just to for the next step. So you get plus 1 times x minus 2. And then from here, you can factor the common term, which is x minus 2. So you get x minus 2 times 2x plus 1, right? That comes from here. So it's x minus 2, which we had originally, x minus 2 times 2x plus 1 times x minus 2, which means that the polynomial can be written as x minus 2 squared times 2x plus 1. So the zeros are 2, which you get from here. It's a double root, which is another way to say, this should say multiplicity of 2, and then the other 0 is negative 1 half. Okay. All right, I'll pause here for that, for you to copy that, then we'll continue to the graph. Okay, I'm going to move on to the graph then. For the graph, just like the do now, we have, three major steps. We're first going to graph the x-intercepts, or the zeros, right? In this case, it's 2 and negative 1 half. Noting that 2 is a double root, so it's multiplicity of 2, right? that we got from here, right? X minus 2 squared, multiplicity of 2. Then we're going to find the y-intercept. In this case, it's going to be 4. Um, actually, let me get rid of that. Yeah, for the y-intercept, it's actually easier just to look at the original polynomial. So if you plug in x equals 0 for each of these, you get 4, right? And so the y-intercept is 4, and the end behavior is as x goes to negative infinity, y goes to negative infinity, as x goes to infinity, y goes to positive infinity. So that came from, sorry, I'm going to scroll up again, that came from x cubed, right? So odd power, 3 is an odd number, and then positive leading coefficient in positive 2, which gives us this end behavior. Yeah, so yeah, multiplicity is the exponent, and then yeah. So yeah, another way to say that is how many times the zero appears. But yeah, you can tell from the exponent. In this case, it's x minus 2 squared. So 2 has a multiplicity of 2. Negative 1/2 has a multiplicity of 1. Okay, because it's just 2x plus 1 to the first power, technically. Okay, and then for the do now is like x uh, plus minus some. It was x plus 2 to the fourth power, so that's multiplicity of 4. Okay. All right, let me move on to the graph. So again, we're going to graph the zeros. So what I would do in your notes, like, so this is the Desmos graph, obviously. So this is like the exact graph, but if you were to graph this normally on paper, you would do like negative 1/2 here, 2, which is a double root, so we're going to bounce off the x-axis, right? 2 is an even number. And then the y-intercept is 4, which is here. And then the end behavior starts at negative infinity, goes to positive infinity. Okay, so I would just draw a sketch of that, like this. Goes through the x-axis at negative 1/2, then the y-intercept at 4, and then it goes to 2, and it bounces off at 2 because again it's a multiplicity of 2. 2 is an even number, and then it goes to positive infinity. Okay, so again, it's not expected that you draw the exact graph. Obviously, this is just a sketch without a calculator. Um, but yeah, this is what we have given this information. Okay, all right, I'll pause here and then we'll move on to the practice question for, let's finish. All right, I'm gonna move on to the next question unless someone still needs the graph here. Okay, all right, for the first one. All right, so these are actually polynomials from yesterday's classwork, so you should have this information already. If not, that's okay, I'll show it again here. But yeah, first we're going to use the rational zeros theorem, so plus minus p over q. So the factors of the constant term, negative 6, are 1, 2, 3, and 6. The factors of the leading coefficient, in this case it's 3, so it's 1 and 3. So it'll be 1, 1/3, then 2 divided by 1 is 2, 2 divided by 3 is 2/3, then 3, and then 3 divided by 3 is 1. We already had that already. 6 divided by 1 is 6, and then 6 divided by 3 is 2. Okay, so these are the possible rational zeros. Okay, from there you would test the zeros, and then you would see that 3 is a zero of this polynomial. You have the leading coefficients here, so you have 3, -4, -13, -6 for the synthetic division. Drop down to 3, multiply, you get 9, add that, you get 5, multiply, you get 15, add that, you get 2, and then multiply one more time, you get 6, which gives you a quotient of 3x squared plus 5x plus 2, remainder of 0. Okay, pause here. And again, I didn't go through these just for the sake of time. But yeah, we see that 1 and 2 are not zeros of the polynomial. Okay, I'll give you a sec to catch up on copying, and then we'll finish. Okay, so let me continue from here. So again, we're going to factor this quadratic. So since it's a quadratic, we can just factor, right? We don't have to like use synthetic division again to break it down further. So we're going to use the AC method again, right? Because 3 is not 1. And so we get 3 times 2, which is 6. And then we had to think of two numbers that multiply to 6 that add to 5, which is the middle term. That'll just be 3 and 2, right? Okay, so we're going to rewrite 5x as 3x plus 2x. So it's going to be 3x squared plus 3x plus 2x plus 2. And then I'm going to factor the first two terms. So factor 3x out. You get 3x times x plus 1 plus 2 times x plus 1. And from there, I'm going to factor x plus 1. And you get this as your factoring. X minus 3 times 3x plus 2 times x plus 1. So the zeros, therefore, are going to be -1 from this last term. Then we have 3 from the first term, and then 3x plus 2 gives us -2/3. And actually, I'll write this in order of yeah, those are the three zeros. Okay, so -1, -2/3, 3. Each has a multiplicity of 1. Okay. Okay. All right. Does anyone still need to copy this part? Factoring. All right. Now I'll move on to the graph. Okay. So finally, we have we're gonna find the y-intercept. In this case, is -6, as you can tell from here, right? Just plug in x equals 0. You get 0, 0, 0 minus 6. You get -6. And then the end behavior, as we can see, it's 3x to the third is the leading term, so that's an odd power and positive leading coefficient. So it's going to go from -infinity to positive infinity, and this is how you write the notation. So as x goes to -infinity, y goes to -infinity, and as x goes to infinity, y goes to positive infinity. Okay. All right. For the graph, we have this. So here are the zeros. I'm going to graph 3. We also have -1 and -2/3, which are very close to each other on the x-axis. -6 is the y-intercepts. And then other than that, we have the end behavior. So that'll tell us how to connect these intercepts. Okay, so we have this. Each of them has a multiplicity of 1, so they do cross through the x-axis. Yeah, something like that would be sufficient. Like that. Okay, that's how you draw the curve, at least on paper, right? Okay, so let me stop here. I'll post the lesson plan on Google Classroom. I already posted it, but I'm going to make some updates to it so you can see the other problem, question 2. But yeah, let me close with announcements while you finish copying this. One, there's SGI today, per usual, 247. Secondly, reminder that the quiz, the current uh, initiative is that we're gonna move it to Monday since some of you are taking the SAT. It's gonna be the same topics and questions. I just moved it to Monday because of the SAT exam. Now, if you have any objections, I'm gonna let you, like, you can still tell me by tonight. Let's say midnight. Let that be the deadline. Otherwise, I'll change the day to Monday. Okay. All right. But yeah, other than that, if you're done copying this and you don't have any further questions, you're free to go, and I'll see you tomorrow.
Thank you. Have a good day.
Thank you.
All
Have a
right.
good
Thank you,
day.
you too.
Have a good day.
Thanks, you too.